Kotlin supports inheritance, as you'd come to expect from any object-oriented language. And in Kotlin, the base class for all classes is any. So if I create a class here, let's call it customer again, and we can see that I don't actually have to type any, but if I do, it doesn't give me any error, so it's any, and we can actually navigate to this. And this is a class, which is the base class, and we can see that it has a bunch of members, such as equals, hashcode, and toString. So very much similar to Java as we're accustomed to. So as I mentioned, we don't have to explicitly put that a class is inheriting from any. Now, let's take this customer and let's say that we want to actually create a base class for it. So we're going to create a base class that is person. And here I have a person class, and now what I want to do is I want to denote that customer inherits from person. So we use a colon and then we do person. And I'm going to use default constructor in person. So as you can see, that the default constructor, that means that there's nothing explicit, so it's parameterless default constructor. Now notice that I get an error. And the issue here is that in Kotlin, by default, all types are final. And you can see that basically the IDE is telling us that, right? Saying the type is final, so it cannot be inherited from. This is contrary to languages such as Java or C#. In Java, for instance, if you want to inherit from a type, you can do so. The only time that you cannot inherit from a type is when that type class is declared as final. So in Kotlin, we have the actual inverse. So here, customer is inheriting from person, but it cannot because person is by default a closed class. So I cannot inherit from it. To do so, what I have to do is add the open modifier. So you can see here that I've added it and the error is gone. Of course, if I'm using IntelliJ, I can just hit Alt-Enter and it says make person open. So now I can easily inherit from the person class. Much like inheriting from person classes, we can also obviously override members. So let's go ahead and create a member for person, and we're going to call it, for instance, validate. It doesn't take any parameters. Now if I come here and set override fun validate, you can see that it's giving me an error saying, again, validate in person is final and cannot be overridden. So much like the classes, we need to declare members that we want to override as open too. Once we do that, we can then basically just override the behavior of the actual member. And obviously, creating the customer class is very simple. There's no tricks around it, and we can see that we have access to all of the different members that we're overriding. In the inherited class, we can also create a constructor, and if we want to refer to the constructor of the base class, we can use the super keyword. So now this is saying that it's calling the constructor for the base class. Now we can see here that it says the supertype initialization is impossible without a primary constructor. In secondary constructors, if we want to refer to the constructor of the base class, we can simply do so by adding the super keyword, and this will then call the base class constructor. One other thing to denote is, let's say I want to do a special customer here. So now I'm going to inherit from person. And now in this case, again, there's no issue. I can inherit from person, and if I come here, I can do an override of validate. Now, if I want to inherit instead of from person, but from customer, again, here I need to mark customer as open. And I could also do an override of validate. However, if I don't want the special customer to override validate, what I can do is mark this final in customer. And now I get the warning saying that validate in customer is final and cannot be overridden. So there is a final modifier in Kotlin which indicates that any open member function cannot be overridden in inherited classes. If we were to declare a function validate, it would cause a conflict because it says that it's overriding the supertype. So it does make us aware that there is an actual member function as part of the base class. One restriction that we removed in Kotlin 1.1, which exists in 1.0, is the ability to have hierarchies when it comes to data classes. So if we look at the code here I have the open person class, and I can actually create a data class, which I call, for instance, customer entity, that inherits, let's give it some property, for example, name string, that inherits from person class. And as I mentioned, this is a restriction that we removed in 1.1. And it's very useful in the cases where, for example, we have a hierarchy of data objects that we want to persist with an ORM or whatever, and that it requires some level of inheritance.